In the last segment, we talked about the CP index. This is the CPK index, which is, in many people's opinion, a much better measurement because it takes into account where the process is with regard to the center of the specification. So let's delve into it. While the CP provides a measure of whether a process is capable of meeting engineering specifications if, capital If, the process was optimally centered in the middle of the specifications, moving the process average to the middle of the specs may be harder to achieve than one might expect. So you can't just say, well, let's just twist this knob and all of a sudden we're in the middle of the specification. It may be very difficult for a variety of reasons. The CPK goes a step further by accounting for where the process average is with respect to the center or middle of the specification. In reality, the CPK is a much better indicator of process capability, how capable the process is in meeting engineering specifications, than the CP because it does factor in where the process average is located within the specifications. CP and CPK are usually reported together because the CPK indicates how capable the process currently is, and the CP gives a good indication of how capable the process might become if we can somehow shift the process average to align with the center of the specification. In determining the applicable CPK value, one must calculate two different CPK values and then take the lesser of these two values. So you'll calculate two different numbers and you take the smaller one. Here are the formulas. CPK upper, relating to the upper side of the spec, is equal to the upper specification, not control limits, minus your X bar, your average of your averages. And in this case, we're dividing by 3 times the standard deviations, not 6 anymore. The CPK lower is the X bar minus the lower specification limit divided by 3 times the standard deviation. Notice here, upper specification limit occurs first. Here, lower specification limit occurs last. And the reason is generally it's going to arrive at a positive number. Upper specification limit should be larger than the X bar, so it'll give you a positive number. Similarly, the X bar should be larger than the lower spec limit, giving you a positive number. Here are some CPK calculation examples. We're going to stick with our 10 and 22 engineering specification limits. We're going to go with the standard deviation of 2. Our X bar is 16 for this example. Let's scroll quickly up to the top so you can see these formulas again. Lower is X bar minus the lower spec. Upper is upper minus X bar, and of course both 3 times standard deviation. So the CPKL is going to be our X bar minus the lower spec limit divided by 3 times the standard deviation. So X bar 16 minus lower specification 10 divided by 3 times the standard deviation, and that arrives at a CPK of 1.0. The CPKU is going to be the upper specification limit minus X bar divided by 3 times the standard deviation equals 1. In this particular case, it typically doesn't happen this way. Both CPKs are exactly the same. CPK equals 1. CPK equals 1. That's what gives you the CPK of 1. And the CP is also going to be 1 in this particular case. Now, let's say our process average is shifted up here. Again, the different shapes are the same width. The CP is still 1. But the CPK is going to be lower than 1 because it is not perfectly centered. Similarly, CP is also 1 here. Again, it doesn't take into account where it's at with regard to the process center line, but the CPK is not going to be 1. Here's a note. CPK equals 1 does not necessarily mean that the tail-to-tail distance equals the total specification width. In this example, the CP and CPK both equal 1 because the process average is perfectly aligned with the middle of the specifications and the tail-to-tail distance equals the total specification width. You could have a CPK of 1 with a CP greater than 1 in certain situations. Here is another example. Same specification limits or standard deviations 2, our X bar is 13, and so the CPKL is going to be our X bar minus our lower spec, and divided 3 times this, and you come up with 0.5. You do the upper, and you come up with 1.5. Therefore, CPK equals 0.5, the smaller number. Not the bigger one or the average, the smaller of the two numbers. In this case, our CP equals 1 because this distance is the same as this distance, but the CPK is 0.5 even though CP is still 1. The process average is located here as shown. In this example, we have problems on the lower side of the spec, so that is why we use the CPK lower value. The lower the CPK value below 1.0, the more defective parts we are likely producing. The 1.5 would try to send us over here, but we don't have a problem here. Our problem is here, which is with the lower CPK value, so that's why you always take the lower one. In certain cases, you could have a negative CPK. It does not happen very often. It occurs when the process average is outside either the lower spec limit or the upper spec limit. Remember our formula for the lower CPK calculation? It took the average minus the lower specification limit. Here, our average is lower than our lower specification limit, so therefore it's going to drive our CPK negative. In a similar vein, upper spec limit minus process average or X bar. This upper spec limit is going to be lower than the process average, which will drive your CPK negative. It doesn't occur very often. It's just information. You're not going to see it on exam 2B.